Major new NASA Titan landing update. A fascinating new rotorcraft project, NASA's Dragonfly mission will investigate Titan, Saturn's biggest moon. Dragonfly is slated to launch in 2028 and land in 2034, traversing Titan's varied terrain to investigate its chemistry and look for evidence of life. For more than 2 years, it will run on a radioisotope generator, which is the first time NASA has flown a rotorcraft on a planet other than Mars. We hope to learn more about the beginnings of life and Titan's potential for habitability thanks to this mission. Number 10. Mission concept and objective. A rotorcraft lander will be sent to Titan, Saturn's largest moon, as part of NASA's groundbreaking Dragonfly mission to investigate its rich organic chemistry and determine whether it might support human habitation. Titan's rich nitrogen atmosphere, lakes and rivers of liquid ethane and methane, and a complex array of organic compounds created by atmospheric photochemistry make it unique in the solar system. Dragonfly will be able to fly over Titan's varied and difficult terrain, including dunes, impact craters, and perhaps cryovolcanic areas, thanks to its novel rotorcraft design, which consists of 8 rotors placed in a dual quadcopter configuration. By collecting and examining surface materials and atmospheric constituents at several locations, the mission's main scientific objective is to look into primordial chemical processes that might be similar to those that gave rise to life on early Earth. By allowing for a thorough investigation of Titan's environment, this method advances our knowledge of habitability beyond Earth, like settings and sheds, light on the chemical beginnings of life. Number 9. Sampling and scientific instruments. In order to examine Titan's surface and atmosphere's chemical and physical characteristics, Dragonfly is equipped with a number of advanced instruments. 2 sampling drills that may pierce the surface and gather powdered material from various geologic contexts are at the heart of its payload. These samples are fed into onboard devices like a gas chromatograph and mass spectrometer, which determine chemical compositions and molecular structures, including intricate organic molecules that may be the earliest signs of life. Dragonfly is also outfitted with seismometers to identify Titan's seismic activity, which provides insight into Titan's underlying structure. Dragonfly will separate from the parachute and switch to powered flight with its 8 rotors at a height of roughly 1.2 kilometers. The moon's low gravity, about 1/7 of Earth's, and dense atmosphere make a controlled, safe landing on Titan's surface possible thanks to this autonomous powered descent. Combining cutting-edge rotorcraft flight capabilities with tried-and-true parachute technology, this entry, descent, and landing strategy is a sophisticated technical feat that allows Dragonfly to land undamaged and start its scientific mission. Number 5. Flight technology and mobility. The 8 rotors in Dragonfly's dual quadcopter flight system are designed to fly in Titan's dense atmosphere, which is roughly 4 times denser than Earth's at sea level. Titan's low gravity and dense atmosphere make powered flight easier than on Earth or Mars, enabling Dragonfly to fly between locations that are up to 10 kilometers apart and cover tens of kilometers. Throughout Titan's 16-day night cycle, the rotorcraft will make several brief flights, avoiding dangers and choosing safe landing spots with the aid of autonomous navigation systems like LiDAR, cameras, and terrain relative navigation. Compared to stationary landers or rovers, Dragonfly's mobility greatly increases the scientific yield by enabling it to study a wide range of geologic and chemical settings, including organic dunes, river channels, impact craters, and potential cryovolcanic zones. Number 4. Power source and longevity. The radioisotope thermoelectric generator that powers Dragonfly uses heat from plutonium-2, 3/8 natural decay to create energy. The rotorcraft's rotors, scientific instruments, and onboard systems are powered by this consistent, dependable energy source during Titan's long nights and bitterly cold surface temperatures, which often hover around -179 degrees Celsius. The RTG guarantees that Dragonfly can function day and night for an anticipated mission lifetime of at least 2.5 years on the surface, in contrast to solar power, which would be inefficient due to Titan's dense haze and extended periods of darkness. This durability makes it possible to conduct in-depth scientific research and broad exploration at several locations, yielding a wealth of information on Titan's chemistry, geology, and possible habitability. Number 3. Historical context and legacy. The Cassini-Huygens mission, which orbited Saturn and sent the Huygens probe to the surface of Titan in 2005, is built upon by Dragonfly. Titan's atmosphere and surface were first directly photographed and measured by Huygens, who also revealed a complex planet with methane lakes, river systems, dunes, and organic-rich elements. But Huygens was restricted to a single landing spot and only ran for a few hours. By visiting several sites over many years, conducting comprehensive chemical tests, and delving into Titan's geology, weather, and possible habitability in previously unheard-of detail, Dragonfly will significantly expand this legacy. This mission marks an important scientific and technological milestone in planetary exploration, as it is the first time NASA will fly a multi-rotor vehicle for science on another planet. Number 2. Scientific goals and astrobiology relevance. Understanding Titan's active methane cycle, including the production, movement, and evaporation of methane and ethane liquids on the surface and in the atmosphere, is the main goal of Dragonfly's scientific mission. In order to determine how far prebiotic chemistry has advanced, the mission will look at complex organic molecules that are deposited on Titan's surface and created by photochemical reactions in Titan's atmosphere. One of the main objectives is to look for chemical biosignatures, whether water-based or using Titan's special hydrocarbon environment, that might point to past or current life. Since Titan is thought to be comparable to early Earth, Dragonfly's research is essential for figuring out the chemical processes that could give rise to life and determining whether or not icy ocean worlds inside and outside of our solar system are habitable. Additionally, the data will offer comparative insights that are pertinent to research on exoplanets. Number 1. Significance and technological heritage. By expanding rotorcraft flight technology beyond Mars, where NASA's Ingenuity helicopter demonstrated powered flight in 2021, Dragonfly marks a significant advancement in planetary exploration. Dragonfly will test the limits of autonomous aerial exploration by operating in Titan's frigid and dense atmosphere. Access to geological and chemical conditions that are inaccessible to rovers or fixed landers will be made possible by its capacity to fly over a variety of difficult terrain. Future research of ocean worlds and other intricate organic habitats in the solar system will be made possible by the mission's advancements in autonomous navigation, in situ chemical analysis, and aerial mobility technology. The success of Dragonfly will stimulate new mission ideas and increase humankind's capacity to investigate and comprehend the beginnings of extraterrestrial life. Building on the historic Huygens probe landing in 2005, this version marks a significant advancement in Titan exploration with much improved capabilities and mission duration. We hope to learn more about Titan's chemistry and life supporting potential thanks to the Dragonfly expedition. Thanks for watching our video and don't forget to subscribe.